Good morning, everyone, and welcome to another Fusion Friday. My name is Brian Mogapunsuk.
My name is Alex Alvarez.
And this is a very gloomy-ish kind of California SoCal morning. I don't know how about you guys, how the weather is over there. But yeah, so today we have a special Fusion Friday for you guys. You guys did request that you guys want to see more meshes and STLs. So that's exactly what we're bringing to you guys. And for those of you who are new, Fusion Fridays is webinars that we do every other Friday on Fusion 360 topics. Past ones we've done is meshes. You guys want to see more of that? A lot of CAM, especially for the local machinists out there, as well as like drawings and surface modeling, all the different tools that Fusion has in it. And yeah, so Alex today will be showing us meshes, but since we see a lot of CAM, since he's very familiar with CAM, he'll be actually creating the toolpaths on those meshes, and I'll tell you guys a little bit more about that. And before we get started, I want to remind you guys to please leave your comments or questions in the GoToMeeting chat room, and I'll gladly be monitoring that. And without further ado, I'll go ahead and pass it off to Alex.
Right on. Thank you for that, Brian. All right, guys. Some learning objectives for today. We're going to go over how to handle the overwhelming stress of dealing with an STL, right? So STLs themselves aren't that bad, but when you're tasked with maybe programming or adding some sort of toolpaths to the STL, it can be kind of difficult, right? So we kind of want to cover that here today, show you some of the workflows and some of the mistakes that I've seen people make throughout the time that I've been here. We're also going to talk about how to fine-tune that STL for critical tight tolerance regions, right? So for the most part, you wouldn't be dealing with tight tolerances if someone sends you an STL. Sometimes, though, when you are doing rapid prototyping, you do want to make sure that maybe certain areas of the model are up to spec or to whatever the customer is requiring, right? So we're going to go over how to tackle that issue there. How to convert your STLs to BREPs. And why. And then, of course, the dreaded warning, right? So warning, this mesh contains a large number of facets. Usually when you try to convert a mesh body to a BREP, you sometimes see this warning. A lot of people don't know how to tackle it or how to go around it. Hopefully today we can walk you through that issue. And then, of course, we're going to be adding toolpaths to some of these STL models. So why STLs? Or better yet, what is an STL, right? So an STL is an abbreviation of stereolithography. So if you guys are familiar with 3D printing or additive manufacturing for that matter, stereolithography should be pretty familiar to you guys, right? So SLS, stereolithography, laser sintering, is a form of 3D printing. So that's because, again, STL files are most commonly used with some sort of 3D printing or additive manufacturing methods. Now, again, the STL, the backronym, standard triangle language or standard tessellation language. So we see two key phrases there, right? Triangle and tessellation. So if we take a look at the model, again, this is an STL file. If you guys look at it closely, it's built up of essentially thousands upon thousands of tiny triangles, right? So these are essentially 3D triangles. So that means that they have some sort of depth to them, if you will. And that's essentially how your model gets sent over or imported into Fusion 360, for example, right? So again, you can start seeing how that becomes an issue or a challenge when creating toolpaths, because again, you're not going to be able to select any nice curvatures or any nice surfaces to start deriving some of these toolpaths. So why even work with STLs in the first place? Oftentimes, that's all we have to work with, right? We go to war with the army that we have. Sometimes maybe your boss or your customer scans the model, and then that's all they're going to send you, right? Usually when you scan data, that's how it comes in as an STL file or a mesh. Oftentimes, too, we see that is customers send you the STL model because they want to protect the IP, right? So intellectual property, they don't want to give away the dimensions. Maybe they want to keep some of that data to themselves until they're ready to really go forward with that model or that body there. All right, so let's go ahead and jump into Fusion and start seeing how we tackle some of these issues, right? So before we do start, there was a recent update to Fusion 360. So of course, we'd like to cover some of the updates here as well. Really, the most notable update that I'm going to be talking about is related to the sketch functionality. So again, if we click on the sketch, most of you guys may be familiar with, having a little arrow here pointing up. So essentially what that did was it brought up that command up to your taskbar up here, right, or your toolbar. Now, though, we see that we have these 3 little dots, right? So if we expand those 3 little dots, we see that we have a couple options here, right? So now, of course, we do have that option to pin to the toolbar, but we also have this option to pin to shortcuts, right? So let me go over to, let's say a slot in this case, right? So center to center slot. Let's say for whatever reason I use that a lot, I can go ahead and pin it to my shortcuts. So now when I start a brand new sketch, right, if I hit the S key on my command, right, you get these sketch shortcuts, right? Now you see that you guys have a few shortcuts here already built in, right? So again, those are the ones that I've already added to my my shortcut command. So again, if I go over to the sketch, go over to slot, pin to shortcuts, hit S on my keyboard, notice that the center to center slot appears, right? So I get it. A lot of people are saying, well, that's not exactly the hotkeys that we've been requesting. So Brian, I believe, has the article with the updated or the updates that Fusion 360 recently got. So in there, they do mention that this is a step towards adding those customizable hotkeys, right? So
yep.
Hopefully if you guys have some time, read over that, and that can explain a little bit better on where Autodesk plans on taking the customizable hotkeys.
And I'll go ahead and post that in the chat room right now, the link to the blog talking about the hotkeys. It's going to be like you create your own custom ones where if you recall if you hit F on your keyboard, that's the 3D fillet. You can create your own. Maybe you can hold the up key and F, and then that can create a 2D fillet because there's no hotkey for 2D fillet yet, and things like that. And that's going to be coming out soon from Autodesk.
Yeah, so along with the update, they fixed a couple bugs that some people would mention, right, or brought up. There's also single line text, right? So again, you guys can read over the document and see why single line text would sometimes benefit you, and use that whenever you guys like. All right, so let's go ahead and jump into a model here, right? So again, we have an STL model. Seems to be some sort of a mount. Again, if we zoom in, we see that it's comprised of really thousands of triangles, right? So let's go ahead. Again, we've been tasked with machining some sort of prototype for this. And then the only critical region that we want to focus on then is going to be this hole here, right? Let's say needs to be within spec. So we need to make sure then that we machine this hole as closely as possible to what they asked for, right? So again, we're in the model workspace. A lot of people still aren't too familiar with how to upload models. That's pretty straightforward, right? You start a project, whether that's a new project or maybe an old project that you already have. Just go into upload. After you click on that, select the files, and then just hit upload here on the bottom, right? So it's pretty straightforward and pretty easy to upload your models into Fusion. All right, so once you have the model into Fusion, we would want to go into the CAM workspace, right? So for those of you guys that aren't familiar with the CAM workspace, it's pretty straightforward. The workflow that we're going to be following is from left to right. We're going to create our setup, add toolpaths. Again, if you guys have Fusion 360 Ultimate, you do get 4th and 5th axis capabilities. And then after we lay out those toolpaths, we want to make sure that we simulate, right, have no collisions or have no unexpected movements. And then finally post out to our machine. All right, so first things first, let's go ahead and create our setup. Right, so if you guys have been using the CAM workspace for quite a while, you'll notice that something's different, right? When I click on setup, usually we see the stock defined around the model, right? This time we don't. Let me go ahead and make some room here. Right, so let's see what's going on. So if we zoom out, we see that we have, first off, the coordinate all the way down here, right? Our work coordinate system. If you zoom in, you see that you have essentially a tiny little stock reference right here, right? So a lot of people forget that we have this little model section, right? So this model section is essentially going to tell the software, okay, that's the model that I'm going to focus on for creating toolpaths, right? So in this case, there's nothing there. That's why it doesn't see which body I'm going to be selecting, right? So let's go ahead and make sure that we select this initial body. Notice too that you don't have to really convert that STL file into a different body. You don't have to convert it into a different file extension. You can drive toolpaths off of STL files, right? So that's one of the key points that I want to get across here. So we're able to get the stock preview of the STL file, right? Again, selecting our stock, it's at relative size box. Notice that I'm in millimeters as well. So let me go ahead and change that real quick. Change that to inches and click OK. All right, so I'm in relative size box. Again, I get some weird dimensions for our stock size. I can just change that to a fixed size box, get some nicer values down there. The work corner system, again, is positioned center block of the stock, which is fine with me. So I can just go ahead and click OK. All right, so we got part of it done. We selected the stock. We picked where our work corner system was at. Now let's go ahead and start adding some toolpaths, right? So again, I want to do a roughing strategy. Like I mentioned, we're just going to focus on this area here. So let's go ahead and try to do some sort of 2D adaptive strategy, right? So let's go ahead and select our roughing strategy. Again, our tool is, if you guys notice, our tool orientation is like this, right? So this is going to be kind of killing two birds with one stone here, but I'm going to be talking about positional milling, right? So in this case, we're assuming that we have a 5-axis machine. Again, we're going to want to rotate the part this way. And notice that my work corner system, though, is positioned in the wrong orientation, right? So to do that, again, if you guys have Fusion 360 Ultimate, you guys have this little option on the bottom, the tool orientation. And that's essentially how you're going to tell the software to rotate the part, right? Or essentially this is how you're going to be telling the machine to rotate it in respect to whatever work corner system you had originally. Now, again, when working with STLs, you don't have the ability to select on faces, right? Usually we're able to select this face and it reorients the work corner system accordingly there, right? So in this case, if we zoom out again a little bit, we see that we still have that these planes here, right? So let's go ahead and select this plane there. And my x-axis is going to be going this way, right? All right. So now that we have that, let's go ahead and pick some geometry, right? So pocket selections. Which pocket do we want to machine? We want to machine this pocket right here, right? So we zoom in here, right? What's going on? I'm not able to select any geometry, right? So that's, again, it's an STL file. First off, we don't even have nice geometry to select, right? So it's not going to allow us to do that. So let's zoom out a little bit. Let's figure out a better way to do that, right? So we tried using a 2D toolpath. Again, 2D toolpaths really need some sort of geometry to work off of, right? So whether that be a face, some sort of edge, some sort of geometry or chain to drive that 2D toolpath. Now 3D toolpaths, so work off of the body that you have, right? So it looks at the stock, it looks at the body that you have inside, and then it tries to remove as much of that stock as possible until it gets to, or as close to, the model as it can, right? So that's what we want in this case. So let's go ahead and try a 3D adaptive. So again, selecting our tool. In this case, let's say I can use a 1/2 inch flat. There we are. And then selecting our tool orientation, right? So same thing for the 2D adaptive, right? So in this case, we don't even see the tool orientation, and that's because we don't have it checked on, right? So if we check it on, we see that we have those planes up here. So once again, the z-axis is going to be this one right here. X-axis is going to be perpendicular to that plane there. Just reorient that. Okay, so we have this selected. For machining boundary, again, I wanted to look at the entire model or the entire boundary of the model, so I don't necessarily need to select anything there. So what I do want to contain, though, is the heights of it, right? So again, if I left it as it is now, the tool would try to machine all the way to the bottom of that part, right? So typically especially when people are starting off with 3D toolpaths and they're not too familiar with how they work, I'm often I'd preach that a lot of people should just select the tool and just select the machining boundary and then click OK and see what the toolpath gives you. So again, if you guys aren't too familiar with 3D toolpaths, typically try to stick to that workflow. If you guys come into the passes tab and try to change some of these options, and the toolpath does something that you guys aren't familiar with, it's harder to go back and figure out which one of these options made that toolpath act the way it's acting, right? So in this case, all I really want to change here then is the heights. So the bottom height, I can do model bottom. And again, if I knew some of these values, I can go ahead and input the values. But for now, I'm just going to kind of use the eyeball method, get somewhere close to the bottom there, right? So that's going to be fine with me. Okay. All right, so there's our toolpath. Again, it's a roughing toolpath. So by no means am I going to have nice surface finishes yet. We can go ahead and simulate it, right? So let's go ahead and simulate that. We can turn the stock on. Again, the option that I like to stay with for the toolpath is tail. And it just shows, the toolpath as it already goes through it. So I can speed some of this up. And of course, I can go back into the toolpath, fine tune it if I need to, maybe change the retraction policy, right, to get rid of some of these high retracts. But for now, that's gonna do it for me, right? So now let's go ahead then, and let's say we're gonna rotate the part this way. We want to machine the bore here. So first off, we can go ahead and do some sort of a facing operation here for the top, right? So again, for that, I would probably use a 3D horizontal, right? So again, if you kept your cursor over the 3D horizontal toolpath, it would show you what that toolpath is looking for, right? So it typically looks for some sort of a flat face, right? So it looks at the entire model. Anywhere you have flat surfaces, the tool is going to try to machine up to that flat surface, right? So it's definitely a good finishing strategy, especially if your model has a lot of flat surfaces. Right, so again, our tool comes in this way. Let's go ahead and reorient that. Tool orientation. Z-axis is going to be this one. X-axis, I can change it to be this one right here. There we go. All right, so then once again, right, we have to contain it or contain the heights, right? Because again, if I kept it like this, it would try to machine this other flat surface that it sees here. So let's go ahead and just contain it somewhere around there. And then for passes, we can do a manual step over, right? And then the maximum step over, we can do, I don't know, 1/4 inch. And then 1/4 inch there as well. Click OK. Right, and then there's a finishing strategy for that flat surface. All right, so now that we have that, let's go ahead and try focusing then on this board here, right? So again, I would probably use maybe a let's try a pocket clearing, right? Pocket clearing would probably be a nice toolpath. Again, notice that I have to do the tool orientation again and go through that whole process all over. So I can go ahead and cancel that. My 3D horizontal toolpath, again, it's already set correctly. Maybe the tool, I'm going to need to change it, right? It's not going to fit all that great in there. So, but really, that's going to be the only thing that I need to change, right? So I can just right-click on this, create a derived operation, right? So it's going to take all the parameters that drive the horizontal toolpath, and I'm just going to be creating a different toolpath, right? So I'm going to be using a pocket clearing instead. again, like I mentioned, I'm going to be changing the tool that I'm using. So in this case, I want to, let's say, go with a 1/4 inch flat. All right. The passes, I can go ahead and just change the height. Maybe this time I do want to go a little bit below that, right? So that's going to be fine for me. Passes, again, it's a 1/4 inch tool, so maybe I wouldn't want to use a 1/4 inch step over. So in this case, I can do some sort of expression, right? So again, if you guys aren't familiar with how to use expressions, you can just right click on the parameter and edit the expression, right? So in this case, I'm going to do tool diameter. That's 0.2, right? It's 20%. Okay, so again, if you guys need a list of the expressions that are driving some of these toolpaths, we can go ahead and look for them. And Brian can probably send them to you guys through the chat. So here it's telling me, okay, it's a little bit higher than your maximum step over. So go ahead and change that. Maybe this one, well, I don't know, minimum step over 10 thousandths. Stock to leave is enabled. That's going to be fine. And just click OK, right? So once again, let's see what kind of toolpath it gives us. All right, so here we go. Gave us a toolpath. And notice that it's trying to machine the rest of the model here, right? So again, this goes back to selecting geometry and containing that toolpath to some sort of area around this model. But again, like we've been talking so far, we don't have any geometry to contain that boundary, right? So again, let's go back into the model workspace. I'm going to want to create some sort of a sketch to contain that pocket toolpath, right? So first things first, I do want to make sure that I capture the design history. So if I do need to go back, make a change to the sketch, I can always just edit that sketch on the bottom here of the timeline. Again, change that to millimeters, inches. And the way you capture design history is you right click on the very top of the node here. The last option is going to be capture design history. Okay, so now notice that we have this little timeline at the bottom. Now what I can do is start a circle, right? And it doesn't really matter which plane. It doesn't matter if it's on the top of that face either. I just want to make sure that we contain that toolpath, right? Somewhere around here. Now, again, it doesn't have to be perfect. It's going to look at the boundaries of the model, right? So it's going to know not to machine the rest of the model, right? So again, let's go into the pocket operation, edit that. Geometry, the machining boundary is going to be a selection, right? Because I'm going to select the sketch that I just made. So notice that it turns green, right? So a lot of people get confused with the machining boundary and the stock contours. You want to make sure that you have the machining boundary selected, right? If you would have done stock contours, then it probably would have given you a different toolpath, and it wouldn't have probably worked, right? So in this case, I selected the boundary. Again, I contained it using the heights tab, right? So I don't need to have the sketch again perfectly centered. And we see that we have the pocket toolpath now ramping down to that hole. Right, so then this leads us to the how we're going to get, or generate a nice finished pass for that, right? So again, maybe the pocket operation works, right? And maybe we don't leave any stock, and maybe that's a nice toolpath, but I want to still go back in there and then just do one last finishing pass, right? So typically for that, we would use a 2D toolpath, maybe a 2D contour, right? We just want to follow the edge of that circle. But as you guys have been seeing, we don't have any geometry to drive that model with, right? So let's go ahead then and see what we would do here. For that, we're going to need to go back into the model workspace. Let me just stop this sketch real quick. All right, so we're going to be starting a new sketch. So we hit the little drop down for sketch. Notice that, again, we're working with the STL, so we have this little option here that says mesh. Now we want to do a mesh section, right? So it's going to create or project, essentially think of a slice plane that slices this mesh, and then it's going to create or project that mesh onto that plane, right? So which body do we want to project? We want to project this one. Now, again, Brian talked about this in his, I believe, 2 webinars ago, or maybe 3 webinars. That's already on our YouTube channel. If you guys want to learn a little bit more about STLs or the workflow that Brian uses to tackle some of these STLs, go ahead and go to our YouTube channel and find that video there.
Yeah, it was the recap video that we did on the Fusion 360 meetup that we had in Costa Mesa, California here. And I pretty much showed the create mesh section, which is what Alex is showing you guys right here, which creates not a sketch yet of the STL of the silhouette of the STL here.
Yeah. So notice that again, if you had a plane, maybe you could have selected the plane, the slice plane, and then projected the sketch onto that plane. In this case, we don't have a plane, right? So we just automatically selected the mesh body. Again, we can position that slice plane to be wherever we want in respect to that model. In this case, it needed to select this little portion of the model accordingly, right? So that's what we want. Let's just go ahead and click OK. All right, so if we take a closer look here, we see that we do have that little projection or that projected sketch, right? So now what we want to do then, once again, let's go into Sketch under Mesh. We want to fit curves to mesh section, right? So again, Brian talked a little bit about this and he went into depth on what this does. But you're essentially just going to derive some of this geometry and convert it to, maybe into a spline if you want to use that. But for me, what makes the most sense is converting that data or that geometry into a circle. Right, so which mesh section do we want to convert? That one that we just created. And so we click on that. Oops.
So essentially, the orange lines that you guys see there they're not a sketch yet. It looks like a sketch, but then it's just a representation of the mesh that he has.
Yeah.
But the tool Alex is using now, is going to pretty much overlay the orange lines or the reference lines.
Yeah. So what happened there, guys, is that I had already exited the sketch. So just you want to make sure that you're still in that mesh section. Once you are, you can go ahead and click OK. Right, and then we have essentially that mesh section there, and it overlays that circle on top of it. Right. So we turn that mesh section off, we notice that we just have that plain circle that we essentially converted, right? So let me turn this one off real quick. Now we can go back into the CAM workspace. Again, we have that 2D adaptive, we have the horizontal toolpath, we have the pocket, kind of roughing that bore out. Now I can go in there, use a 2D contour, right? Again, I can use that same 1/4 inch flat. This time I do have to actually go back in here and select the tool orientation once again. We can go ahead and turn on the origin, right, if we don't see it. Okay, so that's going to be fine with me. And then just select that sketch there, right? So if we take a closer look, again, by default, the heights for that is going to be the selected contour, right? So again, we can do model bottom, and again, just kind of use the eyeball method. We want to make sure that we go a little bit lower than the bottom of that hole. Somewhere on there would be fine. And that's going to really be it, right? So we can go ahead and click OK. And we see that we get a nice toolpath, finishing toolpath, to finish that hole out, right? So again, this is a rare scenario, actually, if you actually wanted to maybe create some sort of exact toolpath or exact geometry. If you wanted to be even more exact, right, we can edit the toolpath, go into passes, and let the machine operator do the calculations for that hole, right? So once you actually mill out the hole with this toolpath, let's say it's off by a couple thousandths, you want to make sure that you set this compensation type to where. And then that way the machine operator can go into the machine controller. Maybe it's off by a couple thousandths, right? He inputs that difference into the machine controller. And then you're going to get that exact hole diameter, right? So if that's what you guys are really worried about, go ahead and change that compensation type to where. Okay, so we can go ahead and click OK. we can regenerate that, right? So click the entire setup, Control G on your keyboard, and it regenerates the entire toolpaths. We can simulate that real quick, right? So we can do simulation. Finish an operation there. Roughing pocket, and then we finish off with our 2D construct.
And you don't necessarily need to use the create mesh section method to create that circle, but it is a good way to find kind of like the center of that circle. And then you can go back later with the regular sketching tool and create your own defined diameter or radius of that circle that you can for sure know that, you know, the size of it.
Is exact. Yeah. So so that's to give you kind of a reference point, right, for the center of the circle there. All right, so let's go over to our next example, right? So we just covered how to add toolpaths to an actual STL model. Let's go over to the bracket over here. So again, now we have a bracket. Now this time though, let's go ahead and convert the bracket to an actual body representation, right, or B-rep. Again, notice that right now I can't really select any edges. So if I expand the bodies drop down here, right click on mesh body, right, we have this option to mesh to B-rep, right? Now again, a lot of people sometimes don't even see that. You want to make sure that you are in the modeling workspace, right? Notice here I changed into the mesh workspace. If I were to right click on that, I don't have that option, right? So if you don't have that option, just make sure you're in the model workspace. Go ahead and right click, mesh to B-rep. And then we have that mesh body there. We're going to convert it to a new body, hit OK. And now we have an actual body representation there, right? So let me go back one. And let me do a quick analysis of this model, right? So I can do a sectional analysis, turn the origin on. And if we notice, we were doing a half section or a cross section here. Notice that it's hollowed out, right? So like I mentioned in the beginning, it's just a group of triangles, of 3D triangles that are essentially coming together and building this model, right? So it has no actual solid data attached to it. So now if we, again, if we convert it to a B-rep and we inspect that section analysis once again, turn the origin back on. Right, we actually see that it does get filled up, right, and it turns into an actual body itself. So again, that's one method to actually converting the mesh body to a actual body. Now again, sometimes it might not let you, and that's because you might have some sort of a hole in the mesh. You can either manually go in there and fix it yourself. Again, in the mesh environment, or maybe you can use something like Mesh Mixer and fix the mesh that way, right? So now that we have this, let's go ahead and just create a quick sketch for our stock. Again, we can just do an arbitrary circle here. Once again, it changed into metric units, right? So I'm going to change that to inches. Click OK. And we can go ahead and extrude, make this a new component, right? So this is one of those moments where do as I say and not as I do. What you would have wanted to do here is right click on this and made a new component, right? So again, you can do that in the extrude command, but again, that sketch is still going to be associated with the main parent file, right? So yeah, so the correct method to do that is just right click on the bracket and then hit new component, right? And have everything in that specific component. But now that I already created it, now let's go ahead and just change the opacity level here, right? So we can see through it, kind of see how it looks like inside the stock. Let's go into cam. All right, so once again, let's go ahead and start adding some toolpaths to this. So now that we actually converted it to a body representation, now we're actually able to select geometry from it, right? So if I go to stock, this time I want to use a from solid, right? Which solid? The solid that I just created. My work origin is correct, so that's fine there. Okay. So now what I can do then is, let's say we want to use a 2D adaptive, right? So to start off using a 2D adaptive, I can probably use that 1/2 inch end mill again. Use a 1/4 inch flat. Okay.
And the reason you created that body, that cylindrical body that you made opaque, was so then you can reference it for your stock, correct, Alex?
Yeah. Just I could have even given a dimension, right? So again, usually being it's easier to just create your stock sometimes. In this case, that's what I did. I was trying to create a from solid stock beforehand, and for some reason it was giving it off center, right? So that's why I just decided to do it.
So it's a good workaround to go around something like that.
Yeah.
Right.
Yeah. So notice that I can still see the stock. I can always just go to the my little design history or design tree here and just turn off the stock. In this case, right? We don't need it anymore. So now that I go to geometry, let's go ahead and try selecting some of these outside loops or contours, right? So you guys can already see what's going on. If I hover over some of these, it's taking a weird, like a weird transition, right? So it's trying to go up. This one isn't actually too bad, right? But I still need to close the loop. What I do see a lot of people do is they continue clicking, right? So they continue clicking over here, then they continue clicking over here, right? So then essentially they have 3 different arrows or three different chains. And that's often bad practice, right? You just want to go ahead and select the single loop. You can go ahead and click on it once again, and then start, working your way around that model, right? So we have this little edge here selected, so you can click on that, click on this one, right? So notice that if you pay close attention, that becomes pretty tedious, right? And we don't want to do that. So instead, let's go back into model. Right, and of course, I didn't capture the design history, but let's do that now, right? So let's go ahead and construct an offset plane. Right, so where do we want to offset it from? We want to offset it from the bottom of that model, and we want to go. We don't even need to go up into the model that high, right? So 1,000 of an inch is fine. Okay, so I constructed a plane. Maybe some of you guys can already see what I'm about to do here, right? So I can go into modify, and we have this split body option, right? So let's go ahead and use a split body. Body to split. I want to split this body, which is our splitting tool. It's going to be that plane that we just created. Gives you a nice little preview there of what that splitting tool is going to be doing. Let's go ahead and click OK. Right, so right away we can see how that's going to simplify our lives, right? So now we actually have a nice little face here that we can select, and hopefully it's going to allow us to actually select that edge for our 2D adaptive, right? So we can go to 2D adaptive clearing, selecting our tool, sensor mount, 1/4 inch flat, geometry, select the outside edge there. All right, so now if we click OK, we see that we have a nice toolpath going around the model, right? So that's one of the workarounds, right? Or one of the ways that you can actually manipulate the body representation. Now, again, you would have to take that 1,000 that you guys essentially split off into consideration, right? So make sure that you take that into consideration when creating your toolpaths. Maybe even use stock to leave or change the heights of the tool so that you take that 1,000 into account there. All right. So that's how you convert your STL into a B rep, right? Body representation. So now let's go ahead and talk about how to reduce the mesh when you can't necessarily convert it to a body representation, right? So here we have Mr. Incredible, right? So tribute to the movie that just came out. So let's go ahead and change the mesh body, right? So again, we want to use the mesh to be rep. So in this case, it's not even appearing. Let's see, change this. It's model.
You might need maybe closing the design history could be a thing.
That might be it. Yep. So do not capture design history. Continue. And mesh to be wrapped. Yep. So there it is, right? So yeah, so that's one of the reasons actually why you probably wouldn't see mesh to be wrapped, right? So make sure that you're not capturing the design history. Once you turn that feature off, right click on the mesh to be wrapped, try to convert it, click OK, and then of course you get that warning, right, telling you conversion has been aborted. So let's go into the mesh environment then, and let's see what we can do to actually convert or reduce some of this mesh, right? So luckily, if we hit the little modify drop down, right, we have a remesh, but we also have a reduce option, right? So let's go ahead and do that, being that that's what we want to do. Which mesh face or mesh body do we want to change? Again, if we hover over it, we see that you kind of have to select some of this right here, right? So I find it better or faster to actually click on the mesh body itself. Reduce type, adaptive is fine. What's our reduce target, right? Do we want to change the density of it, face count, or the tolerance? In this case, I want to go with face count. Notice that it's at, what is that, 126,000, right? So again, once you start getting into like the 15,000s, the 10,000s face count, that's when it stops. Maybe, or that's when it starts giving you that warning, right? I'm going to try my luck and try 20,000s. Again, the lower you go in face counts, the less detail you get to or with this model, right? I'm going to go with 20,000s. Again, I can do a preview, but that's going to maybe slow down my computer. It's going to maybe, cause some issues there. So let's keep it at 20,000s. I'm not going to preview it. Click OK. So we'll just let it work for a little bit. Again, working with STLs and working with meshes can be pretty taxing on your computer, right? So you guys want to make sure that you're careful and you're always saving some of the work that you have, right? So we see here though that it's already been remeshed. Again, the mesh size is much more coarse, right? So you can tell straight away. So now let's go ahead and try to do that mesh to rewrap once again, right? So again, we're in the mesh workspace. Let's go into the model workspace. Mesh to rewrap, new body, click OK. Now I still get that warning, right? So the facets is indeed 20,000s, but it's giving you a caution, right? Do you still want to proceed with that conversion? I do. Click OK. And let it work for a little bit. And it does convert it to a body, right? In this case, again, that's it. You probably wouldn't even need to create a body. You can keep it as an STL and then just machine it or add toolpaths that way. And then use the method that I was using, right? So create sketches and then start containing some of these toolpaths to certain areas, right? And then that's going to give you, again, better looking surface finishes. So again, this wasn't necessarily needed in order to actually machine Mr. Incredible, but it could be applied to any model, right? So again, if you do have large facets and you get that warning, that's how you would work around it. All right, so let's get into the PowerPoint again. So that's what I had for today. Again, hopefully you guys learned a few things on how to import your STLs into Fusion, how to create some of those tight tolerance regions or those tight tolerance toolpaths on the model, right? Again, it often isn't common for machine shops or your customers to send you STLs and tell you, hey, I want this within a thou or maybe even half a thou of tolerance. They would actually send you the 3D model, right? And then, of course, how to deal with that issue or that warning telling you that the facets are too high, and how to add toolpaths to your STL files. So with that, if you guys have any questions that you guys had during the webinar, you guys can go ahead and...
Yeah, we have one from Bernie Frazier.
Okay.
He asked, if you had an STL files of multiple tools and wanted to CNC router foam for tool cabinets, would that be possible in Fusion 360 to lay them out, and I'm assuming that's like nesting, and router them all at the same time, or is it not the recommended software for that?
No, you actually can do that. So if you did have multiple STLs, you can actually lay out the entire bodies, right? So do something similar to what I did. The key here, though, is going to be selecting each individual body in your original setup, right? So if you click on just one body, then Fusion 360 is going to focus on that individual or that specific body, right? So whereas if you click on the entire bodies that you have laid out, then it's gonna add toolpaths to those bodies as well. Mm-hmm.
And also shout out to you, Bernie, for waking up at 3 a.m. to watch our webinar from Australia. So thanks for your viewership. It doesn't look like we have any other questions. And if you guys don't have any other questions, I'll write down our emails and number. Reach out to us if you do have questions later. With that, have a great weekend, guys, and we look forward to seeing you at the next one.
Yeah, thank you, guys.
Thank you.